Okay, so today we're talking about writing and graphing systems of inequalities. Our lesson objective is we will graph and solve systems of inequalities. Language objective, we will discuss the difference between graphing systems of equations and inequalities. And a central question, how do solution sets of systems of equations differ from solution sets of systems of inequalities? So far, we've only talked about systems of equations. So when we discuss systems of inequalities, we'll be able to see what the difference is and what our solutions look like. So we're going to graph two variable inequalities as a review. We're going to use the grids to graph the inequalities below. These inequalities are in slope-intercept form, which is y equals, but keep in mind we don't have to use the equal sign. This is just the way the slope-intercept form looks like. Y equals mx plus b, where this is going to be your y-intercept, and this is going to be your slope. Which is rise over run. And then it's a longer word, y-intercept. Let's make that text a little bit smaller. So that's going to be your y-intercept. So that means this is going to be our starting value of where we plot our first point. We're going to use that point to go ahead and plot our second point. And then we're going to review how we do our shading. If we shade up, above, below, if it's solid or if it's dotted. So the first thing we're going to do is we're going to go ahead and use our intercept as our starting point, and our intercept is 6. So we're going to go over to +6. We're going to place a point. We're then going to apply our slope. Our slope is -1, which means it goes down 1 over 1. So we went down 1 over 1 and put our second point. Then we look at our inequality symbol. It's got a line underneath, which means equal to. So we're going to have a solid line. Now it says y is less than or equal to -x plus 6. Less than means we want all the values smaller than our line. So we're going to shade below. Our next one, we have y is greater than x minus 6. We find our intercept, which is -6. We go down to -6 on our y-axis and plot our point. We're going to apply our slope. When there's no value there, that's going to default to our parent function, which goes up 1 over 1. So we're going to go up 1 over 1, plot our point. We're then going to go ahead and make our line. Now, as you notice that we have a dashed line, and that's because we do not have a line underneath. So this is strictly greater than. So we do not include any of the values on our line. Y is greater than, so it's bigger. We're going to go ahead and shade above so we can include all values above our equation. So now I'm going to go ahead and erase the text that I wrote to the side that we used for graphing so that we can see what pops up next. So list 3 ordered pairs that represents solutions for both inequalities. So we want to find stuff that would be shaded in this area as well as shaded in this area. So we can go ahead and we can find points. So one point is -2, 4. If I went ahead and found -2, 4 on my graphs, I go to -2 up to 4. That's included in there. -2 up to 4. That one's also in there. So that one is in both of our solutions. It's in both shaded areas. We have 1, -2. So we have 1, -2. 1, -2. And let's check our next one. -4, -1. So we got a -4, -1. That one checks out. -4, -1. So far, all the values that we picked have been included in both the blue shaded area and the red shaded area. So is 6, 0 a solution to both inequalities? Let's go ahead and plot that. So we have 6 comma 0. So this is right on our line. Because it's on our line, it is going to be included because this one has the equal to sign and we have a solid line. So let's go ahead and put it on this one. This one is also on our line, but this one we do not have the equal to and we have a dashed line. So it is not in the solution set. So our answer is nope. The dashed line and the second inequality ruins everything because it's a dashed line. It means we do not include that value. Okay. So graphing two variable inequalities. If the two inequalities are graphed on the same coordinate plane, how would you identify the solution set to both inequalities? So when we graph it, we have our point, and that's our first line from our previous equation. We're going to shade it. Now on our last equation, our last page, here's our second line. We're going to shade that one. And then we know it's the solution based on the overlapping areas. So this is the only part of the solution set. So you need to find where the shaded areas parts of the graphs cross each other. So it's the double shaded region. So it's got to be shaded by both inequalities. So systems of inequalities. A system of an inequality is a set of two or more inequalities with the same variables. In Algebra 1, we're only going to talk about two equations in our system. The solution set to a system of inequalities includes the set of ordered pairs that makes all of the inequalities in the system true. So all of them have to be true. It can't be true for 2 out of 3. It's got to be true for all of them for it to be included in the solution. When graphing a system of linear inequalities, the solution set is represented by the intersection or overlap of the shaded regions. So it's where they intersect and where they're overlapping. So we're going to go ahead and we're going to solve the system of inequalities by graphing. Then we're going to state whether each ordered pair is represented in the solution to the system by writing a yes or a no. So once again, quick review on graphing. When we have it in this form, we have y equals mx plus b, where b is our y-intercept, crosses the y-axis. That's where we're going to start our problem. And we're going to find our second point by using our slope. Probably should have typed this one too, but slope, which is going to be the rise over the run. So we'll go ahead and start with our first one. This was supposed to be animated, but it's fine. We have plus 2. So we'll go ahead to positive 2, put a dot. Our slope is 2, which means it goes up 2 over 1. And we have a dashed line because it's strictly less than. When it's less than, we're going to shade under. So we're going to shade down here. Our next one, we have -3 as our starting point, as our y-intercept. And we have a slope of -1, which means we go down 1 over 1. And we draw our line. This time it's solid because we have or equal to in our sign. So we have a solid line is when we include that value. So when we have the line underneath. This one's shaded above. So this one is shaded below. This one's shaded above. So my shaded region is going to be over here. This line would also include over here. And this line would also include over here. But this is our matching shaded unit. Shaded region. Okay. So now we're going to look for these points and see if they fall in our shaded region. So we have 0, 0, which would be the origin, which is about right here. So that one would be a yes, because it's right there. We have 4, -3. So we're going to go to 4, -3, which it is. And we have -2, 3. So -2, +3. Well, it's in one shaded region, but it's not in both, so no. We're going to solve the system of inequalities by graphing, and we're going to state whether each ordered pair is represents a solution to the system by writing a yes or no. So this one, we don't have a b, which means it's going to start at the origin, be plus 0. And our slope is rise over run, so it goes up 1 over 2, up 1 over 2. And we're going to connect our line. When we make our line, it's going to be solid because we have less than or equal to. Our next one we have in standard form, so we're actually going to have to solve for it. We're going to do that by subtracting x from both sides. Now we have y alone, and we have y is less than negative x minus 4. So our intercept is negative 4. Plot our point. Our slope is negative x, which means it goes down 1 over 1, down 1 over 1. Plot the point. Remember, dotted or dashed line because there's no line underneath, and it's strictly less than. And then we're going to go ahead and shade. Now, if you're wanting to make sure that you have graphed everything correctly, you can always use your calculator. So if you go to y equals, we have 1/2, so alpha y equals 1, 1/2 x. Now, when it comes to graphing an inequality, there's no way to make it a dashed or line at all, but you can go ahead and change the way that it's shaded. So if you scroll all the way to the side and press enter, you can go to line and you can change it. So this says less than, so we need shaded below. So you see how it's down on the bottom of the graph? That's going to make it shade below. And then you're going to go down to OK and press enter. Now on here, once I solve, this is also shaded below. So I'm going to press enter. I'm going to go down. I'm going to make this one shade below as well. So shade below. Now I'm going to type in my equation that's in slope intercept form. I cannot use standard form here. So I'm going to type in my equation, which is negative x minus 4. I'm going to hit graph. And so this is the first one. This is the red line. My colors are backwards here because of the way the graph is. And I think I made a mistake while typing it in, because it did not start at negative 4 like it was supposed to. Minus 4. Let's try that again. So it's graphing this line right, but it's graphing the red line wrong. Let's try negative 4 minus x instead. No. Okay, I don't know why it's not graphing that line correctly. Negative x minus 4. It's got the right slope, just not the right intercept. So I can change the line to make it dashed. Okay, well, I will figure that out. I don't know why it's doing that. We could also use desmos.com. So now that we have our shaded region, we want to go ahead and look to see if our points are located in there. So we have 0, negative 4. So 0, negative 4. This one is actually on our dashed line, so it's not going to be included. So that's going to be a no. We have negative 3, negative 6. That's in the shaded region, so yes. Negative 5, 0. It's in one of my shaded regions, but it's not in the overlapping one. So that one's going to be a no. Okay. So we're going to do another practice. So we have negative 6 is, so y is greater than or equal to negative 6. So we don't have an x here. So that means we're just going to have a horizontal line at -6. So we have a dot at -6. And we're going to have another dot anywhere on there to make it horizontal. It says or equal to, so it's a solid line. Our next one, we have to get to slope-intercept form. So we're going to subtract x from both sides. We left at 2x is less than -x plus 4. Then we're going to divide both sides by 2. That's going to make y less than -1/2 x plus 2, because 4 divided by 2 is 2, and then that's just going to be 1/2. So we're going to go to +2 and plot our first point. We go down 1 over 2, down 1 over 2, plot our second point. It's going to be dashed. And for this one, we're shading above. This one, we're shading below. So it's going to be this region right here. Okay, I'm going to go ahead and try again on the calculator and see if it fixes the issue that it was having. So we're going to go to y equals. Oh, I think I know what happened and why it's doing that. I am very zoomed out. Yeah, so it was in the right place. I'm just zoomed out so far that you can't tell. So let's get this back into the way it's supposed to be. So this is going to be -6. And -6 is greater than. So we're going to shade above. This one is going to be alpha y equals 1, -1 over 2, x plus 2. And this one's going to be shaded below. I'm going to hit graph. So that's the one shaded above. That's the one shaded below. This is going to be the matching shaded region, which is exactly what I have here. So that's how we use our calculator to check our answer and find our shaded region. Now, write the inequality that shows the graph below. This is where we actually have to write our inequalities. So we're just going to write them in slope-intercept form, and then we'll go from there. We'll remember if we have a dashed line, it's strictly less than or greater than. Solid, it's less than or equal to or greater than or equal to. Shaded below is less than, shaded above is greater than. So we'll start with this line right here. We have an intersection of 6. And it's a horizontal line. So that's HOI, which means horizontal, 0 slope, y equals. So we're going to have y, but it's not going to be equals. It's going to be less than or greater, less than or equal to 6. We have the equal to because it's solid, less than because it's shaded below. And then we have our next line. Our next line goes to the origin, so there's no b, and our slope goes up 3. Actually, sorry, those are going by 2s. It goes up 6 over 4, which would be the same thing once it's simplified. So y, and this is going to be greater than because it's shaded above, is greater than, strictly greater than because it's a dashed line. That's going to be 6 divided by 4, which would go down to 3 over 2 x. So that's how you would solve that. I'm going to use the animated slide. First one's going to start with y. This one's less than or equal to because it's solid and shaded below, and it's the value 6. This one was greater than, just greater than because it's dashed, and then 3 over 2 x because it went up 3 over 2. Well, up 3 over 2 would be about right here, but yeah, that's how it goes with our points. So in class, if you decide to do this in class with us, we're going to be doing our quizzes. And then we have an IXL code that we're going to complete, and that code is SGH. If you have any questions or if you need any help, please go ahead and send me an email. You have a great day.